From the Aishin Broadcast Studio, it's the Amped EV Podcast.
Hello and welcome to the Amped EV Podcast. My name is David, and on today's show, we are speaking with GKN Automotive's Director of Electrical Hardware Engineering, Ben DeLand. Let's get to the interview. Ben, we are amped to have you on the show today. Thank you so much for joining us. GKN Automotive, very well known in the marketplace, especially for things like, axle and suspension components. So where do you feel that, your company sits when it comes to the EV space, the EV marketplace?
Sure. First, thanks for having me, David. It's a pleasure to be on your show. So GKN Automotive is pretty agnostic when it comes to the EV transition versus ICE. So we have a core business of side shafts and drive shafts that serve both ICE vehicles as well as EVs. So when it comes to the transition to EVs, really, we are able to provide everything from full systems for powertrains. So that would be an inverter, traction motor, and gearbox, all the way down to components, to any singular component of those, or even gear sets as a subcomponent of the gearbox. And our heritage is coming from the all-wheel drive space. So we've been developing all-wheel drive systems for ICE vehicles for over 25 years. So really what we can provide in an EV space is solutions that provide the lateral dynamics that our customers are now turning toward in this next generation of EVs. We've provided over 2.5 million electric drive systems to date. Wow. So we've been in the EV space for quite some time as well, starting in gearboxes there from the learnings from all-wheel drive. And yeah, really happy to provide any solution that fits that heritage.
So GKN Automotive, obviously doing a lot of work in the EV space here. Was it difficult to, kind of split your focus between those ICE vehicle components that you've been developing and the EV components, or is there a lot of overlap there?
Yeah, I would say yes and no to make the answer complicated here. So there is a lot of overlap between those products for all-wheel drive systems and EV powertrains. So especially in the gearbox, things like the gear sets, the clutch systems, differential is something used in both products. You have similar lubrication systems, similar bearings. So really a great amount of overlap. The challenge is really in the complexity of the mechatronic system, moving from all-wheel drive systems to EVs. So you typically have much more stringent functional safety requirements in electric powertrains as opposed to all-wheel drive systems. Cybersecurity is also stepped up in stringency as well. So the structure that needs to be put behind that from the engineering side, the way that you're managing the project, it's really a lot more resources in, and you have to be quite a bit more careful of how you're managing it for the quality side. So from that aspect, we have updated our engineering organization to be more systems design driven. So there has been a learning curve, but it's one I think we've adapted to quite well.
You mentioned, having to be more careful from a design side. Can you give me a good example of what you might be talking about?
Sure. Well, if you look at an all-wheel drive system, I'll give you an example of a twin clutch all-wheel drive system. This is a system that allows you to independently provide torque to each of the rear wheels based on torque that's coming in from the combustion engine at the front of the vehicle. So in that case, the safety condition there is that you have some varying torque output that's not controlled between the left rear wheel and the right rear wheel. Can put the vehicle in a bit of an unstable situation, but really the safety case of the destruction that can be caused there is fairly limited. When you're looking at an e-powertrain, you're controlling the propulsion of the vehicle entirely. So the safety case there, if you have runaway torque or torque is present when it shouldn't be, when you're generating torque, this can be a real problem in the safety case for the vehicle. So the scale of damage that can be caused by your system is on a different level. And with that, you need to have the proper engineering controls in place, the proper redundancies in your product to be able to manage for the complexities of a safety system that is much more stringent.
Very interesting and makes a ton of sense.
Presented from the Aishin Broadcast Studio at Babcock's Media.
So, oftentimes when we're talking about EV components, if you ask any, Joe Schmo off the street, what's a component that's in an EV, probably the first thing they're going to say is, the battery, the big battery. It gets all the limelight. But of course, as you've been talking about, there are plenty of other components that are necessary to make EVs work and make them work well. So, from that standpoint, can you give me an example of why it's so important to design something like an EV inverter well for the EV space?
Sure. So first, let's give the battery its proper limelight. So it's the most expensive component in the EV, right? It's probably the key enabler in terms of technology going forward to reach a parity level in pricing with ICE vehicles. But after that, I would say the EV powertrain is the one where we've not yet reached the consensus on the best technology to serve EVs in the EV powertrain. So the EV powertrain is it's consisting of three different components: the inverter, the traction motor, which is generating torque, and the gearbox, which is multiplying and distributing that torque out to the wheels. And the biggest factor in design right now is with efficiency. So you want to convert all of the available kilowatts in the battery to kilowatts that are actually driving the vehicle forward or backward. Anything that is lost to heat or friction or noise is losses for the vehicle. So it's really critical that the EV powertrain is designed to consume the least amount of waste possible to increase the range availability of the vehicle and give the driver a better experience when it comes to things like range anxiety or charging, things like this.
Absolutely. And, of course, EVs have now been, gaining in popularity for quite some time, at least 10 years here. How has this technology really evolved or shifted in that time period?
Well, I think it's the technology has come a long way in the past 10 years. So I like to tell the analogy with combustion engines. They've been under development for 75 to 100 years, where through research and development in the industry, the design teams have really come to the optimal solution or close to optimal solution. And in EVs, let's say mountain of R&D money and effort that has been spent has really been in the past 10 years. So I think over the past 10 years, we've seen massive gains in efficiency, as just discussed there. So losing less energy to waste. We've also seen cost go down significantly through innovation on thermal management, We've seen components come closer together. In first generation EVs, we would see the power electronics, the inverter, often sitting away from the traction motor and gearbox and connected through a cable. And now it's standard practice that those are coming as an integrated package, and with further integration to come, really. So efficiency and cost have improved significantly.
Fantastic. And, as you are trying to develop these different components for EVs going forward, obviously, we've talked a lot about that instant acceleration and the weight of the EVs and having to compensate for those things. What tends to be the largest challenge there? Is it, making sure that you are getting the highest efficiency possible, or is it trying to control those safety aspects to make everything as safe as possible? Is it a cost factor? What tends to be kind of the most difficult hurdle that you have to cross when you're developing some of these components?
Yeah, you've hit on probably one of the main selling points in terms of how fun it is to drive an EV versus a combustion engine. You get that instant torque, you get that fast acceleration. And the industry has really been a bit insatiable in its demand for this level of acceleration. So the challenges there, I think, are really with thermal management. When you have this massive acceleration burst, you end up with losses in your component. So having more efficient designs helps, but there's only so much you can do. You have to manage that heat that is being generated in the components in the end. And there, I think we've seen a lot of innovation with thermal management through oil cooling, through really unique and sophisticated individual component cooling inside the EV powertrain.
Fantastic. Well, Ben, this has been a really interesting conversation, and I think we could go hours just diving into one of these questions, one of these components that you were talking about. So I really appreciate your time here. I would love down the road to be able to really dig into some of this because it's really fascinating stuff. So thank you for your time.
Thanks for having me, David. Really enjoyed it.
Absolutely. Take care. All right, that was fantastic. I think Ben made a lot of really good points there. One being that, we've really only been focusing on creating these EV components for a good 10 years now, where ICE vehicles we've been focusing on for, 75, 100 years. So there's a huge parity there, and there's a lot of work that is going into these EV components and a lot more that we still have to discover. Great conversation. Thanks for joining us. We'll see you next time.